Section 2 is going to get into the theorems that actually prove triangles congruent. We certainly wouldn't want to have to prove 6 pieces of information, 3 angles and 3 sides, every time we want to prove 2 triangles congruent. So there are several shortcuts, some theorems. So if we have the right combinations of sides and angles, we can say that 2 triangles are congruent with just 3 pieces of information. It just has to be the right 3. So there's also some things that don't prove triangles congruent, and so we have to keep them straight. So angle, 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 AAA, does not prove congruent. Because what happens is the angles alone don't prove congruency, because I could blow it up or shrink it and actually make similar triangles that are not congruent. Okay, so if you know 3 angles, you cannot guarantee that they are congruent triangles because it doesn't control the lengths of the sides. Now, if you have angle, angle, side, what this means is 2 angles and the non-included side, the side that's not between them. So if you look at this picture, this is really important. You have this angle, and the side on the outside of the angle. Not the one between, that's going to be a different theorem. That proves congruency by angle, angle, side. You could also get angle, angle, side if your picture, if you had angle, angle, this angle, that angle, those two are congruent, and you had this side. Okay. Notice it's not this one because that would be between the 2 angles. That's a different theorem, which we're going to talk about next. Angle, side, angle, angle, side, angle is exactly what it says. We know the side between the 2 angles. So it's 2 angles of one triangle are congruent to 2 angles of the other, and we know the included side. And so we know this angle, this side, this angle. We know this angle, this side, and this side. And so really be sure you notice the difference between these. The side is between, and this one, where the side is not between the angles. So that's the difference. Again, the side is on the outside of the name, the side is on the inside of the naming. That matters. Angle, side, side, we never use because, first of all, it spells a bad word. But it also doesn't prove things congruent because, again, I can make multiple triangles. When we say we want to prove triangles congruent, I want to prove without a doubt that my triangle will be exactly the same as yours. So if I give you 2 angles and the side between them, the included side of this theorem, and I give your friend the same measurements, you both have to draw the exact same triangle. You have no choice. There's no other triangle that could be made. If I give you an angle and 2 sides, then you could potentially draw different triangles. And then we would not be able to talk about corresponding parts and congruency. Side, angle, angle. Also, I usually talk about this as angle, angle, side. This does prove congruency. So we know 2 angles and 1 non-included side. Okay, it is the same thing as this one. Whether you say angle, angle, side, or side, angle, angle, same difference. This one is different. Side, angle, side. Here, I know 2 sides and the included angle has to be the angle between. So I know this side is equal to this side to this side, and I must know this angle between. In the name, the angle is between the sides I know. Side-side angle does not prove. That is the same thing as our bad word up here. It doesn't matter if you change the order, it still doesn't prove. And here's a picture of how we could potentially have this side here. So if we know this side, we know this side, and we know this angle. That double hash could end up swinging out, or it could swing in and could make two different triangles, and that's why it doesn't prove congruency. Side, side, side is all three sides congruent. Then we can conclude the whole triangle is. So if all three sides match up, we can conclude the triangles are congruent. So these theorems work for any triangle. Okay, any triangle. And in summary, the ways we have that work are side, angle, side, 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 angle, side, angle, and angle, angle, side. There's one special case, and this is only right triangles. Only right triangles, and we call it HL. So if you know a right angle, the hypotenuse, and leg, then you get to say the triangles can be congruent by HL, by hypotenuse leg. Okay, so here's my hypotenuse being equal, my one leg being equal, and my right angle. Now, right angles, right triangles can be proven congruent by any of the other theorems plus this one. So if you're dealing with a right triangle, you have 5 ways to prove it congruent. Any other triangle, you only have 4. In the next video, we'll take a look at some applications.